This is a sample of the information provided as part of the flexible training resources available through HACCP.com. Our training courses are designed to provide training participants with an understanding of food safety and quality system elements and also offer user-friendly assessment activities and competency checklists to complete the training cycle. Validation activities. Key definitions for validation activities. Control measure. Any action or activity that can be used to prevent, eliminate, or reduce an identified hazard. Control measures determined to be essential for food safety are applied at critical control points in the flow of food. Critical control point or CCP. A critical control point is a point, step or procedure at which controls can be applied and a food safety hazard can be prevented, eliminated or reduced to acceptable levels. Validation. The process of gathering evidence to provide a scientific basis for the documented act of demonstrating that a procedure, process and activity will consistently lead to the expected results. It often includes the qualification of systems and equipment. Verification, the act of reviewing, inspecting, testing, checking, auditing, or otherwise establishing and documenting whether items, processes, services, or documents conform to specified requirements. Validation activities development. When considering the development, documentation and implementation of validation activities within food safety and quality management systems, the following information should be considered to ensure effective outcomes. About validation activities. Differences between validation and verification. Identification of food safety outcomes. Identification of control measures to be validated. Revalidation. About validation activities. Many processes within a food safety and quality system require both validation and verification to ensure the ongoing status of food safety and quality. Validation of a process is a pre-production checking of that process to ensure that the requirements of a product can be met, for example, shelf life. The following information is provided as a guideline covering validation steps, validation process and requirements for revalidation. It is important to consider that validation processes are often defined against responsibilities food businesses and regulatory bodies. The scenarios for applications are defined as follows. Food businesses are generally responsible for the validation of control measures. Regulatory bodies are generally responsible for ensuring that the validation systems applied by food businesses are effective, and that the control measures applied by food businesses are effectively validated. Regulatory bodies do participate within associated processes by providing resources such as validation guidelines and control measure implementation guidelines. Validation within food businesses is primarily focused on the collection and evaluation of scientific, technical, and observational information to determine whether control measures are capable of achieving their specified hazard control purpose. The validation process involves measuring performance against a desired outcome, target or measurable parameter. The validation process is generally applied at the time new control measures are applied within a food safety system, or when product or process changes require revalidation. Validation of control measures for food safety management systems are generally intended to be applied prior to the actual implementation of production under the food safety system involved. Differences between validation and verification. The key defining difference between validation and verification is that verification takes place after the validated control measures have been implemented through a food safety system. Verification is the tool used to assess the effectiveness of the validated control measures and to ensure that the validated control measures are controlling potential hazards as anticipated. Verification activities are applied during or after the food operation to determine that the validated control measures have been effectively implemented to achieve ongoing control of the relevant identified hazards. Common verification methods include a review of records to ensure the applied control measures have been applied according to the defined critical limits or procedures. This differs from the act of completing the monitoring activities and records themselves, in that the verification element is to confirm that the control measures were in fact monitored and recorded at the specified frequency according to the nominated procedures. Verification activities can target single or multiple control measures in their application. Examples of this are provided as follows. A single control measure verification activity may include a review of a specific monitoring record to ensure that a control measure has been monitored and recorded at the specified frequency according to the nominated procedures. A multiple control measure verification activity may include a review of microbiological testing outcomes to ensure the product is microbiologically safe and meets the specified microbiological criteria. An instance where the validation activity demonstrates a high level of control over a generally invariable control measure, the requirement to verify the safety of the product may be scheduled at lesser intervals. An example of this may be where an applied cooking step reduces potential microbiological pathogens well below the safe level. In this case, based upon the process validation, microbiological verification testing would not be expected to be conducted for each batch of product produced. In an instance where the validation activity shows that the process meets the microbiological requirements, but not consistently by large margins, more frequent microbiological verification testing should be considered. Validation steps. A structured validation process may include the following steps. HACCP application. Application of the HACCP methodology to determine critical control points, critical limits and control measures. HACCP plans, by their nature, will identify control measures and their associated critical limits where applicable. Identification of food safety outcomes. Identification of the required food safety outcome. For example, a regulatory limit on a specified pathogenic microorganism might be a count of 1,000 per gram. Your food business may decide to set your internal limit for the pathogenic microorganism at 100 per gram, giving you more control over conforming outcomes. In defining the food safety outcomes applicable to your business operation, it is important to consider the financial, human and premises and equipment resources at your disposal to ensure realistic outcomes are set. In instances where no regulatory limits are set, the food business may be required to define a limit which is achievable and is not likely to result in foodborne illness within consumers. Identification of control measures to be validated. Identify which control measures require validation, considering the importance of each control measure to the expected control of the relevant hazard and whether the control measure should be validated by itself, or whether combinations of control measures should be validated together. In most cases, steps identified as critical control points within a HACCP plan will require some form of validation. Validation status of the control measure to be validated. Identify whether the control measure has been validated previously with appropriate outcomes, or whether the control is well established and supported by relevant validation materials. In either scenario, it is important to ensure that the process input, process flow, process equipment and product and process conditions were the same for the previous validation or relevant validation materials. Risk-based application of validation. Apply a risk-based approach to the application of validation. Dependent on the financial and human resources available to complete validation activities, your food business may or may not be able to complete a comprehensive activity for each control measure. For example, you may wish to prioritize the validation of control measures, which if not appropriately validated are likely to result in a foodborne illness outbreak. Control measures with less severity significance can be validated at a later time. In cases where a significant control measure is related to a new product or process variant that has no accompanying historical food safety performance data, it is important that validation is completed. In cases where historical data is used to support a control measure validation, it is of utmost importance that the data used is applicable to the current status of emerging pathogens or identified foodborne illnesses occurring in similar products occurring since the historical data was published. Validation activities. The actual application of any validation activity depends heavily on the nature of the hazards being controlled through the application of control measures and their critical limits. Considerations also need to be made for the consistency of the control measure and the required ongoing accuracy of hazard control required. Whilst the methods of application for validation may vary significantly, the goal of such activities is the same: to ensure the control measure is capable of facilitating safe food. The following references are commonly used as elements of the validation process: scientific or technical literature specifically relevant to the process and product being validated. Verified scientific-based production trials based upon specific identified hazards that show the effectiveness of the control measures under anticipated product and process situations. Collection and review of data from actual production, ensuring that products manufactured are not made available to consumers unless verified as safe and suitable for consumption. Surveys based upon statistical acceptability, for example, where consumers are surveyed regarding their interpretation and application of product labeling instructions for storage after purchase. Mathematical modeling based upon process control and product composition to ascertain microbiological suitability under anticipated conditions. Revalidation. Revalidation should be scheduled and conducted where changes occur to product formulation, process flow, process equipment. Pathogenic microorganisms are detected in numbers much higher than would be reasonably expected to occur within the product considering the applicable process. Identified hazards are detected in proportions much higher than would be reasonably expected to occur within the product considering the applicable process. Previously unidentified hazards are identified within the product or process. Updates to scientific information for specified hazards represent a risk to consumers. Consideration of worst-case scenario. The consideration of worst-case scenario is of utmost importance for any validation activity, as this provides a framework through which validation outcomes can provide a high degree of confidence in the control of potential hazards. When considering validation worst-case scenario, it is important to be aware of the relevant potential hazard, and any associated critical limits and control measures applied to that potential hazard at any step within the process flow. The ultimate goal is to ensure that your validation activity is conducted in a manner that demonstrates the effectiveness of your implemented process controls to ensure any potential hazard does not occur. Examples of applications of worst-case scenario considerations may include establishing the highest anticipated initial load of key microorganisms on raw material or finished product prior to that item undergoing a structured microbiological reduction step or microbiological kill step. Microbiological inoculation of foodstuffs with known pathogens of risk to observe the impacts of microbiological hurdles within such foodstuffs. Subjecting finished products and/or raw materials to challenge situations such as elevated temperature to observe the impact of microbiological growth. Did you know that HACCP.com includes resources that allow you to create, manage and implement GFSI and HACCP-based food safety and quality programs? Improve your food safety and quality skills and knowledge? Train and develop your team to create better food safety and quality outcomes? Find suppliers and service providers to partner with your business? The information and training resources available through HACCP.com include a variety of formats, such as website content, MP4, MP4 and text, MP3, PDF and slideshow. Are you ready to take the next step in your food compliance journey? Visit HACCP.com today to create your profile and access the full versions of our food safety and quality information packages and much more.